Welcome everybody to the GAN course on circular manufacturing processes and technologies. So as you know that the GAN course is a initiative by the government of India, and typically in this course we invite some foreign faculty expert who will be giving a series of lectures, and we'll also be supporting him in organizing this course. Okay, so for this course we have Professor Shojo Takata. He is a Professor Emeritus at Waseda University, Japan. So he will be the main expert person who will be giving a series of lectures on different aspects of circular manufacturing, and he has a lot of decades of experience in the field of life cycle management, life cycle evaluation, and he will share insights both from the fundamental and academic point of view as well as from the industry point of view. Okay, so the lectures will be primarily given by these set of people. So the main expert person is Professor Shojo Takata, and I am Anurup Datta, Assistant Professor in the Mechanical Engineering Department at IIT Hyderabad, and I will be taking a few of the lectures. Besides, we have Professor Venkat Reddy, who will be joining online, and he will give one lecture regarding some aspects of circular manufacturing. And finally, we have Professor Surya Kumar, and he will also be giving some of the lectures, and he will also introduce us to some of the. Okay. So, what in this course, what are we going to look? One is what do you mean by circular manufacturing? Okay, so why circular manufacturing is necessary? The transition from a linear, let's say linear manufacturing or linear economy. Why circular manufacturing is important, and what are the fundamental principles or fundamental framework behind that? So when you talk about that, it will also have a lot of aspects, particularly in the design. So when you are talking about circular manufacturing, the sustainability picture comes into the play. So when you say that I want to make something sustainable, you have to start from the beginning, start from the design process. So we'll talk about design for sustainability, and finally also a lot of information about the life cycle development, evaluation, management will be covered in the series of lectures. Okay, and so these topics will go in much details as as we move forward, and we'll be having close to 10 or 11 lectures over this entire week. Okay, so we'll gradually go deeper into these topics. So organization of the course, so we will have roughly 12 to 13 hours of lecture. So today we have 3 lectures, tomorrow we have 3 lectures, and so on and so forth. All the 5 days we have at least 1 or 2 lectures, and apart from that there will be a group presentation. So people who are present here will be divided into groups of 3 or 4, and so most of the afternoons will be spent on this group activity. So we'll be giving a topic, and then we will brainstorm and come up with some ideas regarding that, and there will be a group presentation on the last day of the workshop on the Friday during the second half. Okay, so each team will give a short 10 to 15 minutes presentation. So further details will be shared in the second half when Professor Surya will introduce in more details to this activity. Okay, and finally on the last day we'll have a short quiz, maybe about for 30 minutes or so. Okay, and eventually the course completion certificate will be given to all of the participants who have attended all the lectures and completed the presentation and the quiz. Okay. So this is the lecture schedule that in the first day, in Monday we have 3 lectures, in tomorrow we also have 3 lectures, and in the remaining days we have 2 lectures on Wednesday, 2 lectures on Thursday, and finally 1 lecture on Friday. So as we go forward, most of the time for you will be spent on the group activity. So that is why the number of lectures keep on reducing as we go into the deeper of the lectures. Okay, so all of the lectures will be streamed online also. So okay, so now I will just give a very brief intro about this circular manufacturing, and what is it all about? Now we'll look into much details in the course. So here I just want to point out a very simple definition of circular manufacturing. This is not a comprehensive definition, just for layman terms. So basically, where resources, materials, and products, they are used, remanufactured, recycled. So these are one of the few of the terms that we will look. There are also other aspects that that will come into the picture, but the primary concept here is that you are concerned about what happens to a product after the use of that product. Okay, so it is not that you use a product and the story ends there. After that, whether you can reuse it, whether you can remanufacture it, or you can recycle it. And what is the primary goal of circular manufacturing? So here we have mentioned that minimize waste and pollution. Okay, but one thing that one needs to think about. So let's say a company decides that, okay, we are not concerned about waste minimization or pollution. Can they afford to not follow the principles of circular manufacturing? Okay, so let's say if some company says, okay, we are fine with our current business models, can we still not, why to go into circular manufacturing techniques? So in this the remaining few minutes, I will show that for a company, it is not a matter of choice whether to go for circular manufacturing or not. It has become a matter of necessity. Okay, because if we look at the world economy and the current state of that, it is must for a company to think in terms of circularity, whether it is today or tomorrow, but that change is going to come eventually. So now, when we talk about manufacturing is intricately linked with the economy of any nation or economy of any entity. Now these are some graphs which you can see, right? From the 1800s, gradually the manufacturing produce went up significantly, and that has a direct link with the world GDP. So typically, which means that if you want to become more and more developed, the main way to do that is you become good in manufacturing. And this is true if you look at these graphs. All of the developed countries which have focused a lot on the manufacturing, their core expertise is in production. They can produce good quality products at a very good rate, at a very efficient manner. So if the story here is that if you want to become developed, you have to become good in manufacturing. So if you want to become an advanced economy, the primary focus should be on the manufacturing sector. Okay. Now, for example, if you see that there is a very close correlation with the amount of production and the amount of value added for several of the world economies. Okay. So almost they follow a very similar percentage, which means that if you are able to produce more, you will be basically you'll be adding more to the economy, world economy. So manufacturing helps in shaping economies, providing stability, productivity, and leadership. So at the end of the day, we have to look at how to improvise our manufacturing, how to make it more efficient. So now the traditional model that has been used for let's say from the start of the industrial revolution, since the last 200 to 300 years, is based on the linear economy. So what happens in a linear economy is that you plan to make a product, you start from here, you take the raw materials from the ore or from the source, you have a factory which will make the products, and finally you send it to the end users through a distribution channel, and the end users will consume the product, will use the product for a certain amount of time, and eventually when that time is over, you just dump them, you just dispose them. So this model is known as take, make, waste. You take it from the raw material from the sources, you make it, and then you waste it. Okay, and so now if you want to follow this model, there are few assumptions here. One is that your resources are infinite. Okay, now 200 years ago that may be the case. Okay, when people are trying to make new factories or new products, the resource constant was not a thought that people used to think. Okay, and also when you are wasting the material, you assume that the earth will be able to absorb all of the waste. But we see that over the last centuries or decades, this is not true. Resources are neither infinite, nor the earth has infinite capability to regenerate from the waste. Okay, so this means that the linear economy, which has been going on for so long, that is only good if these two assumptions are valid. Okay, so what about the viability of the linear model? So if you want to keep on using the linear model for a long time, then you see that this is how the growth will happen. So you want to increase the GDP per capita. Okay, basically you want to become more and more rich, you want to become more and more developed. Okay, but that is closely linked with the increase in the material use per capita. Okay, now today most of the developed countries are at this zone, close to 10,000s of dollars in GDP per capita. Developing countries are close to 10,000 or less than that. So which means that if some developing country wants to become more and more developed, the only way for them is to use more material per capita. And you see that this is a logarithmic scale. Okay, so which means that if you want to make a slight increase in the GDP per capita, you have to make a similar increase in the material in a logarithmic scale. So this kind of changes exponentially. Okay, and this is evident from the world economy that there are no low energy and rich countries. So this is true not only for material but also for the use of energy. So rich countries with a high GDP, they typically use very high energy per capita. So from the material and as well as from the energy point of view, if you want to become more developed, you have to use more energy and more material. Okay, but you can imagine that this is not sustainable. If you keep on, let's say, increasing this, eventually this graph cannot continue indefinitely. Okay, so there will be some limitation somewhere which will force you that, okay, we have to rethink this model, whether this can go on or not. So economy built on the principle of take, make, waste is not sustainable. It is that there will be a certain limit which will stop it from going further. Okay. So why I am saying that the linear growth model is not sustainable? What are the issues here? So the primary issue is that the finite nature of the non-renewable resources. Okay, so if you look at many of the natural resources, maybe it is minerals or some of the rare earth, some of the metal ores, all of them have a finite lifetime. So you see that after few decades from now, the amount of raw material that you have will gradually go to zero. So which means you do not have enough raw material to make new things. So, and this is also, when that happens, when the supply of the raw material decreases, from the basic principles of economy, that will also mean that the price of the material will increase. So here you see that the annual price change in the last 2 decades, it has grown up significantly compared to that of the previous decades. And why is this happening? Because we are gradually moving to a regime where the amount of the material is becoming less and less. So naturally the price of the material is getting more and more. Okay. So because of the finite nature of these non-renewable resources, it is almost very difficult to keep on using this linear growth model. So again the question is fine, this is the problem with the non-renewables, but what about the renewables that can be used? So for example, if you can use a renewable source of energy, okay, so that typically you have an infinite resources. But when you talk about renewables, let's say the water that is used in any industry, that is also a form of renewable. You are using the water and you are basically dumping it in the form of waste. But eventually even that is also not very sustainable. So people have been using water, groundwater for a lot of purposes, for a lot of usage. And there are places on the earth where the groundwater is becoming difficult to obtain. So you are losing a very important source of renewable material also. Okay. So if you keep on indiscriminately using the materials, whether be it non-renewable, whether be it renewable, there is a limit to which it can go. Okay. Eventually you will come to a situation where the amount of material simply is not there. Okay. So again another key point is why the linear growth model is not sustainable is because the way people have been using several of the natural resources, it has crossed some of the key planetary boundaries. What I mean is that there are several, so the entire ecosystem is kind of a cycle. Okay, you take some things from the ecosystem, you give it back, and it is a well balanced cycle. Now if for some reason you take more and if you give less, then that cycle will be breaking, and there is a cutoff point beyond which if you go, then that cycle is not sustainable anymore. And there are many cases where it has been found that people have already breached that cutoff limit, particularly in the case of biosphere integrity, which means today in the last few decades or so, almost 20 to 30% of the bioorganisms have been eliminated from the atmosphere. So that is where we are going. We are actually crossing the limit of a sustainable planet. Similar situation has arrived for the carbon dioxide concentration. It is being said that almost in the last 100 or 500,000 years, the concentration of carbon dioxide today is at the maximum limit. It has crossed 400 parts per million, while the sustainable concentration is considered to be around 200. Okay. So carbon dioxide concentration has increased drastically. Similarly, for the nitrogen fixation, that has also crossed the cutoff limit. Okay, so nitrogen means typically, because of the wide use in agriculture, a lot of nitrogen components are discarded into the water system. Okay, now that will give rise to a lot of algae, lot of sea organisms, and eventually that decreases the big organisms that are present in ocean. So this nitrogen fixation cycle is also on the it has crossed the limit. So now when this happens, which means that our single earth is not enough to sustain our continued economic growth. So we have to think of alternative ways so that these things these key planetary boundaries can be brought within the specified limit. Okay. Now this figure basically says that we are reaching the end of the linear growth model. Now this is a very simple curve which is with time how much material and energy resources are being used over the years. Now if we keep on using this, if we keep on following this curve, the amount of material that we need to use by, let's say, another 10-20 years, it is almost equal to the resources that would require the use of 3 planets. Okay. Now which is simply not available to us. So there is a huge gap in the demand and the supply. Our supply is only 1 planet, our demand is 3 planets. Okay, so this is kind of the limit of the supply and this is the demand. So which means that if you keep on going along this path, your demand will substantially increase that of supply, and when that happens, what it means that the price of the goods will increase. Today if you are able to buy some objects at 100 rupees, if the supply is less, that object will be 200 rupees. Okay, which means you become poorer. Okay, earlier you can use 100 rupees to buy some object, now you have to spend double the amount of money. So if you are in this situation, then naturally the productivity or the well-being of an economy, it will gradually decrease. Okay, so business as usual cannot continue, and this is a fundamental limit which is given by the restrictions of the planet. Okay, because our resources are not infinite. So what is the way forward? So if we say that these are the limitations for the linear economy, then how can we solve this problem? So the way forward, so this is a linear economy which has been prevailing for the last 200-300 years since the birth of Industrial Revolution. But what we need to do is we have to close this loop. Instead of having a straight line, we try to close the loop. Okay. So what we mean is that, okay, we will still have the raw materials which are coming in. There will be design, manufacture, okay, consumption. But after consumption, instead of disposal, we have to look at how you can take those objects back and look at waste so that it can be utilized for further applications. So for example, you can do maintenance instead of just throwing them away. We do maintenance so that you can use it for longer time. We can reuse them or refurbish them for some other purposes. We can do some recycling. Okay, recycling, we can again make sure that you can use the raw materials back to the factory. Okay, and finally there will still be some residual waste which you cannot entirely ignore, but you can minimize the amount of waste. Okay, so the solution for the linear economy is that you have to close the loop and make it a circular economy. Okay, so for renewable materials, it means that you reuse and return it back to the biosphere. Okay, for non-renewable materials, we have to move back and forth between production and consumption. Okay, so which means that you have some product, you use it, you consume it. After consumption, you again find a way to move it back to the production. So this, after consumption, you have to take it and again make it back to the design phase. So this is where the additional steps will be coming into the picture if you want to move to a circular economy. Okay. Okay, so now what will be the advantages if if some business entity or some people think of going into the circular route? So the primary factor here is the decoupling of the growth and the resource use, which means earlier if you want to grow, you have to use a lot of resource. Okay, the resource is coming from the ores or coming from the source of raw material. So if you do not have the source or if you do not have the raw material, you cannot grow. So they are kind of intricately linked. But now what happens is that even if you do not have the source or the raw materials, you still can find a way to grow further. So you can decouple growth and the resource use. Okay, so which means that even if you do not have the raw material, maybe because it is not there, maybe because it has become expensive, you get the raw material from other sources. Okay, so that is the primary advantage if people think in terms of the circular economy. Okay, now this will also help in protect from the rising and volatile commodity prices. Okay, let's say typically we see that today rare earth materials, they are not widely abundant, only few regions they are located, and because of that the cost of the rare earth materials are very high. Okay, and let's say if you want to manufacture something in an electronics, some electronics that you want to manufacture, you might need some rare earth. Okay, and if the cost of the rare earth itself is very high, the price of the equipment will also become very high. And sometimes several geopolitical considerations also come into the picture when your source of the material is only localized to some locations. Okay, and if you look in the past history, a lot of the geopolitical conflicts have actually arisen because of the localization of the raw materials. Okay, so if you are not able to access the raw materials properly, your commodity prices will not be stable, it will be fluctuating widely, and eventually it will rise. It will make the entire process not very sustainable, not very pocket friendly. Okay, at the same time it also helps in becoming more resilient to supply disruptions. Okay, if you're typically let's say if you have a single source of supply, for some reason it has got stopped. Okay, maybe you do not have the raw materials, maybe there is some other factors, then you need to find another source of supply. Okay, now that another source of supply can be the material that you are using as a product consumers. Okay, so you can, instead of going for a fresh virgin raw material, you use those used materials as a source of supply, and eventually if your source of the raw material is disrupted, you can still stay afloat in the business, you can still become resilient to the supply chain disruptions. And moreover, this is also very important, you can reduce the energy footprint, environmental footprint. So it takes a lot of energy. Okay, particularly let's say you have some ores and you want to collect the metals from the ore. It takes a lot of energy, starting from the mining process. The mining itself is a very energy intensive process. Then you have to collect the raw material, you have to put it in a you have to put them in a factory. Okay, so that you can basically from the raw materials you can get the you can put the material in a format from where you can make the material. So this entire process is very energy intensive. Now if you use already the used material, you can actually cut off this entire initial beginning of the energy sourcing. Okay, so that helps in reducing the footprint to a great extent, and so that is how the advantage of this the circular economy or circular manufacturing, it will come into the play. And also there is a tremendous economic opportunity if people go in the circular business. It has been predicted that almost $4.5 trillion worth of untapped potential is there in the entire business of circularity. Okay, so in the next few decades, this this number can go up to 25, and out of that almost 4.5 trillion can come from the circular manufacturing context. And this is spreaded across several factors, several sections. So for example, if the wasted resources elimination play a big role, almost 1.7 trillion it has been predicted that one can save if you are able to utilize the wasted resources properly. Similarly, if we can increase the life cycle, okay, instead of just throwing the material away, you can do remanufacturing, refurbishing, all those techniques. It can also boost the economic opportunity. Similarly, wasted capacity can be eliminated by promoting more sharing, co-owning. Okay, so all of these concepts will be talked in more details as we go into the further of the course. So in this entire lecture series, this is what we will be mostly covering. Okay, what are the basic characteristics or fundamentals which are needed to transition society or economy into a circular economy? What are the guiding principles behind that? What are the basic concepts behind the sustainability, behind the how to do the design for sustainability, how to do the, so you have to think right from the design aspect, right from the beginning. When you are thinking of making any product sustainable, you cannot start to think at the end. You have to think right from the beginning. Okay, so that is known as a design for sustainability. What are the basic tenets of that? And also the life cycle processes. Okay, how one can evaluate, how we can design for increase in the life cycle for the different use cases. And a lot of business use cases will also be given in the entire series of lectures. Okay, so that you can know that this is not only just an academic pursuit, but today many of the companies have already started to think in this line, and in the coming future more and more companies will have to go along these directions. So this is something which is going to affect the entire the economic growth across the entire world. So we will gradually explore all these details in the course. Okay, and so with that I will just stop the introduction section. And so these are the contacts. You already have my information, and we have the TAs who will also be helping you for any purposes. And so yeah, so with that I would like to end the introduction section here. And then what I would ask the participants to just briefly introduce yourself. What is your name, what are you from, and what do you think you can obtain, or what made you motivated towards this subject, so that we can get to know about your background, and what is your what are the options, what are the backgrounds that you are coming from, and about the engineering fields. Because at the core of any manufacturing, you have the engineering aspect, but eventually what happens is, how you can use that engineering aspect in actual use case, in actual model. Okay, so in one part we have the process, that is the the code engineering part, but next comes from there how you can evolve your business. So yeah, so I think with this short introduction, as we move forward into the upcoming lectures, we will gradually get to know more about the different aspects of circular manufacturing, the circular design, sustainability, and hopefully it will be useful to you. And also when you do the participants activities, so that will also enable you to do a lot of use your own ideas and brainstorming some of the ideas. So through that, I think you will be able to appreciate the techniques and the utility of the circularity in the upcoming future.